We talked about our compressor, our discharge line, hot gas line, and how it enters into the condensing coil. So next we're going to talk about the condensing coil. All of this is going to be our condensing coil. In this case, it goes all the way back around this system and the fan's in the very center. So it's just simply a coil. Here's another condensing coil for a refrigeration circuit. This is an entire coil. It's very simple. We notice that the hot gas will go into one of these tubes, probably this top one here, runs back and forth and back and forth. You saw little U-bends, just where it goes to the next tube, down to the next tube, down to the next tube, back and forth, back and forth, back and forth. Then we move air across it. Now remember that the refrigerant is moving under high temperature, high pressure, and the temperature of this refrigerant inside of here is going to be higher than the temperature of the air. So the heat leaves the refrigerant through the coil, this is nothing more than a heat exchanger, and goes to the cooler air outside. We have to have that fan moving air across it. There's many different kinds, but here we can see we got one that's cut open, and you actually see the tubes inside here. These tubes are where the refrigerant runs, and due to the second law of thermodynamics, we have lots of different surface area here, and it's made of a heat transfer material such as aluminum. So we have a lot of refrigerant going through a lot of tubes, and a lot of these tubes touching a lot of aluminum. This increases heat transfer, and these fins are very, very close together. Actually, air will travel through these fins. It's hard to see it on the camera, but they're very close together to speed up the second law of thermodynamics, heat transfer. The problem is that over time, in these running, especially outside, they get dirty. Notice that this one has a whole lot of dirt on it. We left these systems dirty so that we can clean them, and so that you know when you're working in HVAC, you're going to be dealing with all kinds of dirt and stuff. We're going to have to clean these up to keep the efficiency up. Dirt is a great insulator, and it slows the second law of thermodynamics. So with this dirt being on here, we don't transfer the heat like we need to. So it's very important for us to understand this condensing coil. Its whole entire job is to reject heat. Now it's going to be doing this in a few different ways, but we're going to talk about that a little later. First, we understand that this coil is a high temperature, high pressure coil. It's rejecting heat. So when we take our refrigeration system drawing, we're going to take our refrigeration line, and we're going to go back and forth and back and forth and back and forth. This represents the coil, the condensing coil. So we're just going to make a bunch of little loops down here and come out the other side. So we're coming into the coil back and forth, and coming out the other side. Now in reality, this pipe comes in, the discharge pipe comes in, and it divides it into 3 different areas. So I could, if I wanted to get technical, draw 3 individual squigglies all the way down, but ultimately it doesn't really matter. We're still coming in, changing state, and then coming back out. Now we're going to add a whole lot of stuff in here, right here in the middle, up here and down here. We're going to come back and cover all this in more detail later, but what I want you understanding right now is that this system is all rejecting heat. All this is rejecting heat. It's higher than the temperature of the air. So the air is cooler than the refrigerant. Heat leaves the refrigerant through this heat exchanger to the cooler air. Now there's many kinds. We talked about this is what we call a tube and fin. Refrigerant runs through the tubes, exchanges heat to the fins. We also have what we call a micro channel, which is similar to a radiator of a car, where we have a large chamber that the refrigerant runs through, and then it runs these little micro channels right here, and these little bitty holes all of them run through, and it exchanges the heat to the aluminum. And then we're still pulling air through this, so we're exchanging the heat from the refrigerant through the metal to the air. Second law of thermodynamics still applies, different way of doing it. And we also have, you also see some that use a style like this. It's called spine fin coils. We have a aluminum tube that the refrigerant's traveling through, and then it has all these little fins here, so that's actually transferring heat to the air. So air is going to be pulling across it. You got tube after tube, and you're all closely connected together, but it's still the same idea. We're moving air across it. The temperature is higher than the temperature of the air. The heat leaves the refrigerant, goes to the cooler air outside. And when they manufacture this, is pretty cool. They got a how it's made video on this, but it just simply spirals around this tubing. So it's pretty neat how it's done, but it's still heat transfer. This is nothing more than a heat exchanger. So these are all examples of air style condensers. We're exchanging the heat from the refrigerant through this medium to the air. There's other kinds you're going to see as well. When we get into refrigeration, you're going to see water-cooled condensers, which is going to be something like this. We're going to have refrigerant running on one side and water running on the other. Water is actually going to be flowing in the very center, and refrigerant actually is going to flow on the outside. We'll talk about this more when we get to the refrigeration, but stay tuned. It's not always going to be air-cooled refrigeration. So let's make this little note. We're going to call this the condensing coil. So in our notes right here, we're going to call this the condensing coil. And its job is to reject heat. We're going to be adding a lot more of this. I can't say it enough, so don't be settled with this. But it's the condensing coil. Its whole job is to reject heat. Now we're going to be coming into this as a high temperature, high pressure superheated vapor. We're going to be coming out of this coil as a liquid. And we have several things to talk about before we get to that point. But we're going to go in as a vapor, come out as a liquid. It's actually condensing, what's we call a condensing coil. But right now, I just think this whole thing is rejecting heat. Together, the compressor, discharge line, and the condensing coil, we call the condensing unit. Together, they make a unit.